In this video, we'll talk about concept of limits. So before to start with the concept of limits, we have to look at some important points. First point is if we divide 4 by 2. So 4 divided by 2 is equal to 2. This means 2 multiplied by 2 is equal to 4. So 4 is here, 2 is here, and this 2 is here, right? So 2 multiplied by 2 we get 4, 4 divided by 2 we get 2, right? So in this case we call it determinant quantity. It is the quantity that has a specific result. The specific result in our case was 2, number 2, okay? Now what if we have 0 divided by 0? In this case, we call it a indeterminate quantity. Why? Because, for example, if we if we multiply 2, so if we replace instead 2 here, 2 multiplied by 0, we get 0. So 2 multiplied by 0 is 0. 3 multiplied by 0 is 0. And so on, right? So in this case, we call it indeterminate quantity. It is the quantity that does not have a specific answer. So we don't have a specific answer here, right? Here we can have any number. And for indeterminate quantity also, you can have infinity to power 0, 1 to the power infinity, 0 to power 0, in plus and minus infinity divided by plus or minus infinity, 0 multiplied by 0 multiplied by infinity, or infinity minus infinity. So those cases also represent indeterminate quantity, okay? And last one is 4 divided by 0. So in this case, do we have any number to multiply by 0 and get 4? No, right? For this case, we call it undefined quantity. So it is the quantity that does not have a meaning. So this does not have really a meaning, because 4 divided by 0 is something what it can be, because we don't have something to multiply by 0 and get 4, like this one here. We had 2 multiplied by 2, we get 4. Here, if you put something, for example, 2, 3, 4, minus 1 multiplied by 0, you get 0, right? So, but for this case, it is undefined quantity, okay? Let's solve this function. So, when x is equal to 3, we will see that we don't have any problem here. But when x is equal to 2, we will get a problem. And we'll see that, and from that we'll go to the concept of limits, okay? So, let's do it. So, when x is equal to 3, so meaning we replace, instead of x here, x squared, we replace by 3 squared. Instead of x here, we replace it by 3, okay? So f of 3 is equal to 3 squared minus 4 over 3 minus 2. And this is equal to 5, because 3 squared is 9, 9 minus 4 is 5. 5 divided by 3 minus 2 is 1, so we get 5, right? So here we didn't have any problem. What if we replace instead of x by number 2, okay? So f of 2 is equal to 2 squared minus 4 over 2 minus 2. So 2 squared is 4, 4 minus 4 is 0, 2 minus 2 is 0. So you see, in this case we have indeterminate quantity. And we cannot determine the value of the function at x is equal to 2. So you see, when x is equal to 2, we get this problem, indeterminate quantity. So here comes the concept of limits. Limits are the study of the behavior of a function as it approaches, so this is very important, as it approaches a specific number. Let's see this example. So this example will help us to understand the concept of limits, okay? So this example is illustrating the concept of limits. So this is the function. This is the graph of this function, okay? And this is the question: find the limit of f of x when x approaches the number 2. So first, remember that we already saw that f of 2, so when x is equal to 2, is equal to, we replace, instead of x2, we said that it is 2 squared minus 4 over 2 minus 2. And we said this causes a problem because we get 0 over 0, right? So this is indeterminate quantity. That's why you see here, x cannot be equal to 2. Why? Because you see from the graph also, when we go from 2 upward, we see that this is not included. So 2 is not included, okay? Let's start with the question now. Find the limit of f of x when x approaches, so this is very important, approaches. X is never equal to 2, but it is approaching the number 2, okay? So what we will do is, we will approach to number 2 from the left, and we will approach to number 2 from the right, and we will see what values we get on y-axis, okay? So let's do it. When x is approaching to number 2 from the left, you see x is not never equal to 2. Remember that. It is only approaching. We see that f of, until this point, we see that f of x is approaching to number 4, okay, on y-axis. Then what we said here, it is the same here on this table. So x on x-axis, f of x on y-axis. So when x approaches, so x, remember, is never equal to 2. X is not equal to 2. X approaches 2 from the left. So we are approaching here from the left. You see, x is approaching 1.9, 1.99. You see, in the same time we are approaching, f of x is approaching to number 4. Okay, we are approaching to x is approaching to number 2, and f of x is approaching to number 4. This is on x-axis, this is on y-axis, okay? Then we approach the number, x approach to number 2 from the right side, okay? So we read it from here, 2.1, 2.01, and until it is really approaching to 2, but it is never equal to 2, okay? X is never equal to 2. So when x is approaching to number 2 from the right side, we see that f of x is approaching to number 4 also, okay? So in this case, we will read it as follows. You see, limit, okay? Limit of x, limit x approach to, this minus means from the left, so minus from the left, so 2 minus f of x is equal to 4, okay? You see, it is approaching to 4. And since the limit from left side and limit x approach 2 from this plus means from right side, f of x is equal to 4, okay? So from limits from left side and limit from right side are equals, so we say the limit of the function f of x approach the number 4 when x approaches the number 2, okay? So this is very important. X is approaching, always x is approaching to a number, and in the same time, the limit when x is approaching from left and right side to a number, the limit of f of x has to be the same, meaning we are approaching to number, x is approaching to number 2 from left side, we get f of x approach to number 4, and x is approaching to number 2 from the right side, f of x also is approaching to number 4. So they are equal, hence the limit is exists, okay? The limit of f of x exists, and the limit we say x approach to 2, f of x is equal to 4, okay? And this was the concept of limits. In the next video, we'll talk more about limits. We'll see some important rules about limits. Thank you for watching, and see you in the next video.